All right, so everybody, so good morning. We are talking about dimensioning today, and so I'm going to quickly go over with you what some of the conventions around dimensioning are. Okay, so when I say dimensioning, what I'm talking about are the lines on any technical drawing, not the object itself, right? But all the little supporting annotation lines, the lines around it that say this object is this wide or is this tall. If it's a circle, it'll say what the diameter of the circle is, or if it's a curve of some kind, it'll say what the radius of that curve is, or that arc. And so those lines that tell you how big something is are called dimension lines. And today we're going to go over what the conventions are around those. All right, so let's share my screen here and let's go. All right. So just to keep it, just to be super clear, I'm expecting you guys to be taking notes as we go. If you have questions about stuff, please just type in and ask. Okay. All right. So we're talking about dimensioning conventions and just how do we annotate dimensions on a technical drawing. So at this point, you guys should start to write. Okay. So conventions are just generally accepted rules that everyone agrees to follow. All right, so you can have conventions around how class goes. You can have conventions around, I don't know, what's the right way to play rock, paper, scissors, for instance. Everybody understands that before you play rock, paper, scissors, there's certain rules that everybody has to agree to, and you have to say, is it 1, 2, 3, shoot, or is it, do you shoot on 3, or do you shoot after 3, right? So those are just rules that are just everybody has to accept in order for things to go smoothly, and so everybody understands what the rules are. So the main benefits of using conventions when you're dimensioning a drawing is that it eliminates confusion, right? If somebody is looking at your drawing and they see all of your annotations, all of your dimensioning annotations, you're trying to make them so that they're really easy to follow and they're not confusing in any way. Okay. Also, if everybody follows the rules, it makes communication of those sizes much easier to understand. Okay. All right. Just so everybody is aware, I'm going to be posting this up on Google, and so if there's something you don't get, you can feel free to come back and get it a little bit later. I prefer you get it now, though, just so that you have a chance to kind of get it in your notes and ask any questions you have about it. All right, so today we're talking about these conventions, and let's talk first about what types of information are included in dimensioning, right? There's basically 3 different types of information that you would get from dimensioning. So here's on the diagram on the board right now, you see a shape. It's a pretty simple shape. It's got, it's basically kind of rectangular. It's got a circle here. It's got a little cutout piece here and a little angled piece here. The dimensions would be all of this kind of orange stuff around the outside of it, right? And so they'll tell you 3 different things about this object. The first thing that they tell you is the overall dimensions. So like, how big is this whole thing? So you see over here, it says overall, right? So it's telling you, what's the overall dimensions of this shape, right? So how wide is it by how tall is it? So overall dimensions is one type of information that is included in dimensioning. A second type of information you can get from dimensioning information is location. So like where something is. So for example, if we look down here at this circle, that's kind of in the middle of this shape right here, there are annotations that tell you, okay, if I'm looking for the center of that circle, how high is it off of the bottom of the shape? And how how far from the end is the center of that circle, right? So if you were somebody trying to actually make this shape in real life, and you had to drill a hole out in the center of that shape, you would need to know exactly where the center of that circle is. And so the annotations will tell you where the location is of every object in the thing. They might also tell you something like, okay, how far is this edge right here from the edge of where the shape would be, right? So that's another time when location might be one of the annotations given. Lastly, it tells you the size dimension of internal parts, right? So like here's a cutout, and you need to know how big that cutout is. The location would tell you how far over from the end you need to start that cut. But then this size dimension here will tell you how wide that cut is. And this size over here will tell you how far down from the top you need to cut it, right? So there's 3 different parts of dimensions, 3 different types of information you would get. You would get the overall dimensions, you get the location of where things are, and the sizes of internal parts of that diagram. Those are all the 3 things that you should be looking to learn from looking at dimensions. And it's also kind of looking forward on our first midterm test that we're going to have to take. One of the things I'm going to ask you to do is to dimension an object, and I'm going to ask you to make dimensions that look basically kind of like this. So let's talk about what types of things are included in dimensions. So there's a couple of things. We've got, first thing I need you to see is this, right? Everybody needs to write down what extension lines are, right? So extension lines are this, like this line right here is an extension line, and this line is an extension line, this line is an extension line, this line is an extension line. All those things that come off from the main shape, but don't touch the object itself. They just like kind of like helping you to see what is being measured, like from where to where. Those are called extension lines. Okay. Now, what's important about, there's several things that you're going to need to know about extension lines, one of which is that they don't touch the object itself. That's important because if they actually touch the object itself, you might get confused and think that this line just kind of goes all the way up like that, right? So the fact that there's a little break in between the object line right here and the extension line lets you know that this is not part of the object itself. It's just dimensioning extension lines, right? Next, so let's look at this overall dimension here. Like, let's look at the one that's the 4, right? So it's telling you from this line right here, all the way over to this line over here, that is 4 units. It's 4 units wide. Okay? Now, you see the 4 in the middle, and it's got arrows that go from the 4 all the way over to each of the lines. So the 4 is telling you that from here to here is 4 units wide, and the arrows show you what that 4 is actually pointing to. 3/4 here says it's 3/4 of an inch from here to here. Sometimes, like if you see this right here, the arrows don't go from the number up to the line or down to the line. The problem with some of these is that there's just not enough room in between 2 extension lines to be able to write the number and put arrows to the edge of the line. And so sometimes you're going to see dimensions where there's 2 arrows pointing from the outsides of lines in and just the number on the inside. And it's going to be up to you to just kind of make sense of that, right? So this is 3/4 of an inch from here to here. And we see that just because the arrows are coming in from the outside. Pause right here for a second while you get. All right, so we're back. All right, so again, that only happens when the space between the extension lines is really small. All right, so let's talk about different conventions. And I'm going to need you guys to put your thinking caps on. I need you guys to try to figure out what is right and what is wrong here. So if you look at the screen right here, all of this stuff on the left is done correctly. Something about the right is different, and that makes it wrong. So you can feel free to unmute yourself and call it out if you want. If you're going to say the rule is this, blah, 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 blah is right, and blah, blah, blah is wrong, what do you think is right versus what is wrong? Sean, what do you got?
The two on the right half where the three is, it's not facing upright, like the left side.
Like right here?
Yeah.
Sean gets the extra credit for today. Nice job, Sean. Sean is correct. Indeed, what he's noticing is this part right here is different from this part right here. And the convention number one, the rule number one, if you want to think about it like that, is this. When you're writing dimensional numbers, like the 5 here, or the 2, or the 1, or the 2, or the 2.5, when you're writing these dimensional numbers, you always write them facing the same direction, right? So it's called unidirectional. Uni means one, directional means direction, right? So when you're writing these numbers, they should always be unidirectional. And you're trying to avoid doing this, where like some of the numbers are written one way, and the others, you'd have to turn your head to see it, right? You're trying to make it so that every time somebody's looking at this, it's really easy to just figure out what the numbers are, and you don't want them to have to like spin the paper around and look around. Nice job, Sean. So that is the first rule, or the first convention around dimensioning. All right, number 2. What's different from the left, which is the right way to do it, compared to the wrong way to do it over here?
Some of the numbers are inside of the...
And so what's the rule? If you had to phrase it as a rule, what would you say? Jalen, would you agree with that?
Well, I didn't really hear what he said.
Oh, so what's your rule?
Well, I said that like some of the lines are like inside of the shape and like outside of the shape.
Yep. And so the rule should be what? If this is preferred, what would you say the rule would be, or the convention is?
To like leave the lines outside of the object.
All right, both Jalen and Jack getting that one right. So convention number 2 says this: as much as possible, your pencil should be moving right now. As much as possible, keep your dimensioning information outside the object, right? You're trying to preserve the view of the object itself as much as you can. And so you're trying to make it so you can see the actual object. And if you end up cramming a whole bunch of numbers and lines inside the object, it gets harder and harder and harder to see stuff. So as much as possible, you're trying to keep all of this dimensioning stuff on the outside of the object. It's not always possible. Sometimes you have to have stuff inside the object, but you're trying to make it as much as possible. Keep that information outside. Okay, so that is the second convention. Nice job, Jack. Nice job, Jalen. Let's see if Zaki can get this next one. Let's see. Or anybody at home. This is kind of a hard one. I might just give you this one because it's just kind of hard to actually put as a rule. But yeah, it's kind of like the fraction. You're trying to write your fractions in this way with a big number up front and same size, basically, numbers a little bit off to the right. But you're trying not to do this. See, like if you look at this one right here, it could really be confused with 21/4 because it kind of looks like 21/4 and not 2 1/4. Same thing with these. You're trying to make it so it's very easy to see the 2 and it's easy to see the 1/4. And so this, because the 1/4 is really small, and this because it's kind of written in this weird way, you're trying not to write it like that. So anytime you have to write a fraction, you're going to try to write it with the numbers basically all the same size and the fraction with the number over the numerator over the denominator, not in this kind of like diagonal way. If you want to simplify this convention to just show what it's supposed to look like, that is probably the easiest way to do this. All right. Next one, convention number 4. So let me take a second here, right? All right, so in a lot of shapes, you're gonna have circles, right? Or partial circles like arcs, right? So there's a couple of different symbols that you use when it comes to circles. If you look carefully, you see that there's this little circle with a kind of diagonal line going through it like that. That symbol means diameter, right? And so that's saying that the diameter of this circle is 3. So if I measured all the way from here, all the way down to the bottom end, it would be 3 units or 3 inches probably, 3 inches tall as a diameter. Radiuses are done not with the circle here. Radius is done with a capital R, okay? And anytime you have the whole circle, you would use the diameter symbol. And if you only have like a partial circle, you would use the R. Anyway, the convention though has to do with how do you draw these lines that point to the circle itself? These pointers are called leader lines. And the main thing to know about these leader lines is that they should be at an angle. Now that might seem kind of like, who cares, right? It's at an angle, like biggie. The reason why is because if you did it this way, that's shown on the right, the improper way, it can get kind of confused with, these lines right here. Okay, so when you're trying to show somebody how big a circle is, you should draw those lines at a diagonal with a tiny little horizontal line to kind of connect to the number. Now, anytime you draw a circle, you're supposed to let the person looking at your picture know exactly where the center of that circle is. And so whenever you draw a circle, you should draw it like a crosshairs of a scope. Any of you, if you've ever played like any kind of an online shooting game, right? They always have like, not always, they often have a little, like a view that you can see. So when you're showing a circle, anytime it's an actual circle, you are supposed to draw a horizontal line across and a vertical line and a little cross in the center to show the actual center of that circle. That's what lets everybody know, A, that it is a circle, and B, that's where the center point is. All right. Number 5. This is a little harder to figure out. What do you think is the difference between the left side, which is what is preferred, compared to the right side, which is what we are trying to avoid? It's not that this is awful. It's just not as good as this. So what do you think this is better at than this? Key, what do you think?
You want like the longer line at the top and the smaller lines underneath it.
Okay, I got your answer, Connor. What was your answer, Zaki? Okay, that is true. And why do you think that that's good? Because there is a reason why it's good. Not sure? Okay, I'm going to throw it over to the Zoom world. Zoom world, what Zaki said was that over here on the left, the dimensions are given in such a way that it shows you kind of this empty space right here in the middle. And this one, it doesn't show you that. So why is that better, people from home? Kimberly, Nikki, who else is on the call right now? Jimmy, Jaden, somebody help me out. Why is it better this way?
I think it's probably better because you have an actual like showing of how much like one square is rather than just that being 6 and that being 2. because
Okay.
you have spaces that you know like what specifically they are.
That is a good answer. All right, was that Henry?
Indeed, it was.
All right, because I can't really see anybody. All right now, all I have right now is my screen. So thank you. I think it was Henry. So that is a correct answer, right? So the convention that I'm talking about here, the kind of rule is that you're trying to show the dimensions closest to the views that show the true shape of the object, right? Yes, this is the top view of the same object, but it's much easier to see what this 2 is referring to if it's down here when you see like, oh, okay, this is the part that sticks up. All right, that's 2. This is the part that sticks up, that's 2. It's just easier to associate that dimension with the piece itself if you put the dimension near to the piece itself and on the right view, like whether it's front, side, or top. Okay. Moving on to number 6. Is 6 an easy one or is 6 a hard one? 6 is pretty easy, I think. All right. I think it's pretty obvious what's different between what's preferred, which is, where's my thing? Which is what's over here, compared to what we're trying to avoid, which is over here. But why is this better than that? It's all the same information.
The one on the left is better because it shows you it's the exact like markings like 5 inches or 5 feet, whatever. They're all right next to each other. So you can see specifically how each shape measures up next to a different one.
That is indeed correct, which is kind of a hard thing to explain. In many ways, you did a nice job there. So convention number 6 says that we're trying to keep our dimensions grouped close to each other in a way so that it's easier to understand what's going on in the drawing. So for instance, this 5 right here, is the same dimension for the front view as it is for the top view. But by putting it right here, it makes it just kind of like easier for your brain to figure out what each dimension is on both shapes. Right?
Yeah.
It's a trick to help your brain kind of see the connections between the different views. All right. This is related to one that we saw earlier. Sean, what do you think?
Well, I think that, well, what Jack said earlier, all it's like intersecting
Mm-hmm.
and also it's unorganized and not all the dimensions are good. Well, not all the dimensions are on the way part of the
Okay. Okay. Thank you. This one, so earlier we had the rule that said like we're trying to keep everything on the outside, right? All the dimensions and stuff, we're trying to keep them on the outside. This one has one extension line that goes in a little bit, but it kind of has to go in, right? Just so we can see that it's pointing to this particular line right there. But we have the dimension itself over here on the left, so that the only line we really have going across doesn't have to cut through the object so much, right? So by putting, like, for instance, if we look at these 3/4 dimensions up here, you could put them up here, or you can put them down here. They both refer to the same 2 lines, and they both say 3/4. But by putting them up here, we're making sure that our extension lines don't have to cut through the object as well. So that would be preferred as well. So the next convention would be, don't extend your extension lines more than halfway across the view, right? You're trying to keep them as much as possible outside of the drawing. Like this one is just kind of unavoidable, and so that's okay. But you wouldn't want to put it over here because not only is it far from the view or far from the object line itself, but it's cutting through the whole object, and that makes it really hard to see. Okay, convention number 8. So we got all these lines, and so this thing right here is 2.38 inches. From here to here is 3 inches. From here to here is 3.62, and the whole thing is 4.25 inches wide. There's one thing about the way these numbers are written that is helpful. It might not be super obvious, maybe it is, I don't know. Kimberly, what do you think? What do you notice about the way those numbers are written?
That they're all like coordinate from side to side. Like one of them stays on the right and the other goes to the left, and it keeps on going like that.
Nice job, Kimberly. That is indeed the rule, right? If you have to write several dimensions next to each other, stagger the writing a little bit just to make it easier to read. If they were all right above one another, it gets kind of hard to see, especially if there's a bunch of numbers. It gets kind of hard to figure out which numbers are going with which lines. So by spreading them out a little bit, it makes it easier for your eyes and your brain to kind of see those things. For those of you who have finished writing, everybody just take a quick look at this line right here. It's got a long line, a little dash, and another long line that goes right through the center. That's a specific kind of line. When you draw a line that looks like that, it's another kind of center line. So what that means is that this object is actually like, we're looking at a side view of something that is basically circular. So if we were to go up on top of this object and look down, this would be like a circle with a bigger circle coming below it, with a bigger circle below it and a bigger circle below that. This is a center line that shows you that all these things are rotating about this center line right here. Okay, we'll come back to that. All right, convention number 9. Right here we see a shape. This is a from here to here is a location dimension because it's telling us the center of this circle right here. Everybody sees the little lines coming off of the circle and the cross in the center that shows that that's the center point of the circle right there. And this is the center point of that circle. So if we were trying to drill this with a drill press, or if we were trying to make it with a CNC machine, we would know exactly how far over to program it and exactly how far down to program our cutting tools so that it would drill a hole right in the right spot. But you see something different about this compared to this. And there's a lot of little D's. The D's here stand for dimension. There's stuff over here that's crossed out. And they don't exist over here. Why? Let's go from the Zoom world. I got an answer from here in class. Let's go to the Zoom world. Let's see. Who have I not heard?
They could
Nikki.
be like added dimensions, like extra added dimensions.
Yep. So why would we keep them off of over here? Why are they not here? What's good about it here? And we're getting rid of them over here.
Because they could be confusing, or like
Yep.
they're too close together.
It's
And
not that they're too close
same
together.
thing.
There's something else.
like they're explaining the same thing, so that's why they cross the thing
Yeah.
out.
You don't need them, right? Like if you know how big this whole thing is from here to here, and you know how wide this is, and you know how wide it is here, you can just subtract this out, right? And so you know that you don't need that one because you can figure out how wide it is from here to here because you know all these other numbers. So the convention is we're trying to avoid duplicating any dimensions unless it's absolutely necessary. right? And in this case, all those things that are crossed out, you don't need them there. It's just duplicative. All right, I do want, before we leave this slide, I want you to notice this right here because this comes up a lot in all the drawings we do. Right here, you see 2x diameter symbol, and it's pointing to this circle right here. Over here, we see a diameter symbol that's been crossed out and another diameter symbol that's been crossed out pointing to this one. You're going to see this a lot. If it says 2x or 4x or 8x or 6x something, it means that every single one of those things has the same dimensions. So in this case, whatever the diameter of this circle is, there's 2 of them, 2 times that. So this circle is also going to have the same diameter. So anytime you have like the same circle, the same shape, the same everything, you can very often just say 2x, whatever that dimension is, right? So if it's a radius, if it's a fillet corner, if it's something else, you can just say how many of them you're talking about. So that way you don't have to write it on every single one of them. All right. Last one, I think this last one, pretty straightforward. This is good, that's bad. This is bad because it's confusing, right? All those lines crossing, much easier to see if you do them this way. The smallest dimension is closest to the shape. Slightly bigger one is slightly farther away from the shape, and the overall dimension would be the farthest from the shape. So we're trying to keep our extension lines, we're trying to keep those lines from crossing as much as we can. And the way we do that is like it says, the shortest dimensions, the ones that are really small like this, we keep that close. And the biggest dimensions, like the widest ones, we keep those the farthest away. And that's it.